My name is Rick Racey, and I'm actually a lighting professional. I've been doing it for about 35 years. What I'm here to talk about is LED lighting and relationships with reps and other things that are relevant to what you're here for today. But just to give you a little idea of who I am, I got 35 years in the lighting industry. Everything from electronics distribution to electrical distribution to rep agency, contractor, manufacturer, lighting designer. I've had my hands in almost everything. So I do have some background that makes what I'm going to talk about relevant. But what we're going to talk about today is manufacturers' reps, how they actually are going to fit into your new marketing profiles and what you do. LED product specifications, I'm going to cover high-level LED information, commercial LED lighting and low voltage and where they fit in together, and then how you're going to access this world. So primarily what we're talking about is what are dealers? I mean, when I look at dealers and when I look at from the lighting rep perspective or manufacturer's perspective in the commercial lighting industry, a lot of times they're looked at as master distributors, somebody who carries an excessive amount of inventory or volume of business that allows them to get better pricing. How does the rep fit in? Well, reps basically represent the manufacturer. I've worked for 4 different manufacturers now. So when I go out there and I develop branding and rep programs, I'm hiring reps to take that product into the market and either sell it through distribution, through contractors, or get it specified. And to me, 90% of my efforts are to get it onto a specification, to actually work with an architect or an engineer who's going to design an entire building, put my product in there among the other 40 or 50 or 100 different products, and at the end of the day, a contractor ultimately buys it, installs it, and the job is done. And that ranges everything from hotels to hospitals to sports lighting. I mean, I've had my hands in all of it. I've done so many parking lots I can't even remember. Distributors basically buy the product from a manufacturer and sell it. The rep, his job is to put that product on the spec. Whether or not you bid on it or have that relationship with him to get a chance to bid on it is very big. So if you've got a relationship with the rep and you know that he's going to put something on a spec, you have a better chance of writing that order. You're not going to write it if you don't know him or if you don't deal with him, because he's going to try to circumvent you if you're not going to be a partner that's going to help him get that business. Now, granted, sometimes they're going to be writing that spec with a large package of product, and in most cases that's what it is. So you'll find that you need to work with him to make sure that you get a chance to bid that. So those are things that reps actually do on a regular basis, but I'll tell you why that's important in a minute. And then of course the engineer and the architect. You heard earlier, know your target customer. How's that important to you? Well, the architect is the target customer in a lot of cases. Sometimes it's not. I've dealt with so many architects that will not touch lighting. They want to design the building. They will call me sometimes and say, I want you to work with this engineer. And some of them will say, Rick, I want you to do the design for me because I want to control what we put onto our project. But reps work with people over long periods of time. I have an engineering friend of mine who just became a principal of one of the largest engineering firms in the country. I've known him for almost 20 years. So when I was working with him as a worker bee, we developed a great relationship. He trusted me. Now when he's a principal, he's telling all of his guys, call Rick, trust him. Well, contractors may or may not have that ability to go to that guy and say, I want you to use this product. But if you know the rep who's got that relationship, he can go to that engineer and say, this is the product to use. And that trust thing that everybody talks about is already embedded in there because he trusts them and they trust you. That's part of the biggest thing that a rep does is long-term relationships with a lot of customers that you're going to end up dealing with. So how does that work in? Well, manufacturers hire manufacturers rep who then deal with the architect, the engineer, lighting designer, who then deal with the contractor, installer, distributor, dealers, and users. You know, if you want to call them the middleman, they can be, but more often than not, they're trying to look at the big picture on a lighting design. How am I going to take landscape lighting and incorporating it in with the parking lot lighting, incorporating it in with the building design? So reps work on the behalf of the manufacturers. Most manufacturers don't go out there and hire individual salespeople to go out and call on the markets. I hire 60 reps around the country that then go out and call on the specification community, or in some cases just distributors who are going out there doing the same work, or contractors who are going out there and doing the same work, or ESCOs or energy services providers. You know, it depends on the market that you're in. A lot of what I do is high wattage outdoor area lighting. I do everything from 50 watts to 500 watts. So when I'm doing a landscape lighting design, mine usually involves lighting the facade of a 40-story building. So to me, that is considered landscape lighting because I'm lighting the physical space that people are looking at. So again, you talk about LED product specification, and we've had this dialogue. How does this product fit in with the rest of the LED lighting market? Well, when I look at the product, I don't compare it to other LED lighting manufacturers that are in the landscape lighting low voltage arena. I look at it for what I'm used to, which is high-end specification. So when I look at what they're building, I compare it to people like Zumtobel or Visa or high-end, very expensive lighting fixtures. Because when I'm specifying, I have to get a feel from an architect or an engineer what quality of product they're looking to put in at what price point. And a lot of it has to do with not only how's it going to perform, but aesthetics. So if I know that I'm working with a lighting designer that is doing a ballroom, and he's putting Visa wall sconces and Visa pendants in, he already told me that he's not afraid to spend money. So now I'm not going to go to him and say, well, this is what you should use for this product. I'm going to go with the highest end product I can find and say, this is your benchmark. Now as a specifier, that's important to you because the higher I specify that, the more money we make. And I always look at it from a perspective that my reps, my contractors, my distributors, all the people I deal with, we're all in the business to make money. So I want to try to guide that whole process to the highest amount of money that there is. What's going to help you guys to sell more of that product is better understanding of the technology changes, better understanding of the technology terms, and understanding how color impacts the visual task. So why all the technical details? Anybody remember the Yugo? A Yugo is a car, okay? Well, if you're just selling a car, it's hard to differentiate between that and that, because a car is a car. But the reality is that you know that those are not the same thing. One of them is worth significantly more than the other, and it's all in the details. What is it built out of? What is the performance characteristics? What is the quality of the product from a longevity standpoint? All those are important, and from a technology standpoint, understanding how you get to that point is very important, especially when you talk to people like me, because I've carried an LC certification for probably 14, 15 years now, from the day that they incepted. So why I do that is because when I talk to an architect or an engineer, they look at that and say, I've been tested to understand that I know about lighting. I recommend to everybody, get certifications, whether it's LC certification or landscape architecture lighting certification, become a member of the local IES chapter, know the people that you're dealing with, know the people that you're going to be interacting with, because that actually tells them something about you without you having to say it. So again, sometimes it's easy to know the Yugo from the B&W. These are the kinds of LED lighting fixtures I've actually seen in the market. And people will sell it and say, oh, this is an LED lighting fixture, it'll do a great job. Reality is it doesn't compare to some of the other things that we have to show. The energy is much lower than traditional conventional lighting, and the longevity of the product is much higher. But the biggest thing that most people have to understand about LED lighting is how that lighting fixture actually works. All LEDs dim over a period of time. Now, what I always have to remind engineers when I'm talking to them is that LEDs will fail, and they will fail actively. What happens when an LED is defective, or a lighting circuit board is defective, or a driver's defective, it'll fail instantly. Now, if it doesn't fail quickly over, say like the first 1,000 hours, chances are it's going to last for its entire lifetime and just dim down over time. Anybody here been involved in landscape lighting for long enough to remember mercury lighting? All right, so when you take a mercury vapor light, everybody knows that you can put a mercury vapor light in a light fixture and it's going to last for almost ever. It will dim down to almost nothing, but it will always burn. Problem is, it always burns and draws the exact same amount of wattage. So when they switched over to things like metal halide, inherently they actively fail. LEDs do not. So we create things called L numbers, which in this case, L70 is a very popular number that people use. It's a life period at which 70% of that light is still visible, but anything below that, it's below 70%. So what happens is the operating hours will go out there over a period of time. You see where it starts at 100%? Most people don't know that an LED light actually increases in lumen output for about the first 1,000 hours. So it goes up and then it starts to gradually go down over a period of time. What that number is basically over a period of time. In this case, that one was showing a 50,000 hour life cycle of an L70 for an LED light. We deal in terms now of L90s. Most of the time, depending on the temperature that we're operating in LED, I'm going to tell people that it's going to have 10% of its lumens are going to be gone at this period of time. 9 years ago, I started doing LED lighting development. Somebody came up to me and asked me what the L70 was on a fixture that we just launched. And it was actually one of the lighting engineers from Hubble Lighting who I work with. And when I told him the number, he asked me if it was realistic. And I said it was a third-party test with an in situ test. So it was actually tested in the fixture, in an environment, and accelerated tested with the extrapolation methods they use. It was 1.06 million hours. I actually have LED extrapolations in the 2 million hour range. I publish numbers like L90s of 190,000 hours on certain fixtures. And the reason is the heat sinks are so good that they keep the temperature of the LED so low that it doesn't burn out rapidly. It burns out over a long period of time. Drivers, on the other hand, fail fast. That's never going to be a fixture life. That is an LED life. Now, what I say that for is I had to give a class at the IES one year, and it was about how do you judge one fixture against another. Well, what I told them is that you look at the L number that they're publishing, validate it, don't ever just take it for what it says, because find out who did the test, find out whether it was an in situ test. Once you see that, then you can set a benchmark and you tell everybody else, if you're going to do this, this is the benchmark you use. So make sure that every other manufacturer they look at meets that same benchmark. If they're giving you an L90 number, make sure everybody's giving you an L90 number. Where that gets to is that you can overdrive an LED, and one of the things that I ran into years ago was Cree came out with an LED fixture, and you mentioned Cree earlier. They were claiming that they could drive the LED fixture, and they were driving it at 750 milliamps, and they were failing everywhere. So what they do, they came out and they said, well, that's overdriving the LED. We've decided we're going to drive our LEDs at 350 or 525 milliamps. And it took me 2 years to convince people that the drive current that you're using is not what creates that life cycle. The temperature the LED's operating at does. Their problem wasn't they were driving it hard. Their problem is they weren't getting rid of the heat. So we were out there telling people we can drive our LEDs harder and eliminate the quantity of LEDs just because it's cheaper, but we're not overdriving them because they tell us we can drive them to a certain level. What we found out is that we had to really go out there and educate the population. What I do now is we have a tendency to think more in line of put more LEDs in, drive them lower and make them last longer. Why? Because LEDs are cheaper today. The reality of that was if you drive an LED, you can take one LED, drive it at a certain drive current, and you'll get a certain amount of light. If you take two of them and drive it at half the drive current, you get the same amount of light. Or you take an LED and you double the drive current, you get twice the light. What ends up happening is that life curve changes. So more power equals lower efficiency, which is equated to droop. Take a number of LEDs and drive them harder, you get more light out of them. It's a balancing act. Sometimes we trade off a little bit of life for a little bit more efficiency or a little bit more light output. And then you end up looking at, well, what is the life cycle cost? What do I need that light to last? You know, when I'm talking about LED lighting, a lot of times we're talking about 190,000 hours to L90. If you only want the light fixture to last 15 years or 10 years, then why worry about that number? Make sure that what you're putting in is going to last the lifetime that you expect it to. If you look at it retail, everybody doesn't know it, they average about 7 years in retail that they've completely renovated the space. So why am I designing lighting systems that are going to last 20 years in a retail space? I'm designing them for 7 to 10 years because I know they're going to swap them out anyways. So there's many opportunities for optimization. In this case, we've done a number of LEDs versus a specific drive current to tell you what that light is going to look like, the amount of light, the cost, all those things. It's just a trade-off. Lumens per watt is basically how many lumens you're getting out of a light fixture and the amount of wattage. Candle power and candela. It's more important in flood lighting and landscape lighting than it is in area lighting, because nobody really looks at those terms when they talk about that. But when I'm lighting a sports lighting field, I need to know where the center beam candela is, where that actual maximum amount of light is. Foot candles, how you measure light on a horizontal or vertical plane. Correlated color temperature. That's the color of the LED. A lot of times people confuse that with CRI. So when I tell them the color of the light, it's 5,000 Kelvin or 4,000 Kelvin. When I tell them what the CRI is, it's a percentage of the light level based on a constant, which happens to be the sun. Beam spread, that's your angle or NEMA angle. Optics, things that we put over an LED to create that light pattern. You'll see that some manufacturers or some products have no optic at all. If I were to put an optic over it, I can actually control that beam pattern a little bit better, so then I can give you more light where you want it and less spill light, those type of things. The candle power, that'll actually equate out to what we look at when we talk about lighting. International candle was redefined again when they started looking at the black body, which a black body was how do we heat up a certain metal to a certain amount of temperature, and it creates a certain type of light or amount of light coming out of it. Correlated color temperature is just basically where on this black body that lighting fixture falls in. So if you hear somebody say 4,000 Kelvin, 4,000 Kelvin falls in right there. CCT and color of the light is different. If somebody talks to me about light, when I talk about correlated color temperature, they usually want to know what color white it is. So if they talk about 2,500 Kelvin, that generally means they want something that's close to high pressure sodium. When they talk about 5,000 Kelvin, they want something closer to daylight. But 5K has got a lot of blue in it. So I try to push people into that 4K to 5K range. But I had somebody say, Rick, what can you give me that's closer to high pressure sodium? I said, well, do you want the CCT or do you want the color? And they did not know the difference. So if you don't know the difference, CCT is a correlated color temperature specifically along that black body. Color is a visible spectrum. So if they told me they wanted red, it's going to be right in here around 615 nanometers. So when I talk about color, when I talk to specifiers, especially lighting designers, they get more specific. LED lighting does a better job because it falls into a CCT color spectrum more in the white range, but it actually does reflect greens, reds, blues, browns. So those are the things that you look at when we start talking about color. CRI. CRI is one of those things that you guys deal with, and a lot of people will talk about color rendering index. CRI is basically a combination of 7 or 8 different pastel colors, okay? The absence of red removes the reflected red coming off of the device or the object that you're lighting, and you get blue. So what does that mean? Well, LED fixtures that are 70 CRI still have enough red to make that look purple under the lowest CRI of LED. So whenever anybody says you got to have a positive R9 value, it's always a matter of what is it you really want to see, because a positive R9 value does not necessarily mean you're just going to get more red. You get enough red out of a 70, but you're going to pay a lot more for it. Now, I like to talk to lighting designers and keep them right around 80 to 85 CRI. 95 is expensive, you lose a lot of life out of it, but there's going to be people that are going to ask for that. So where do these CRI values fall in? A good transition point right there. Standard LED, 83. Those are good ranges. And I actually like 83 or 80 as a good range, just because it does give you a very good cost value proposition. The original classification was only using those 8 pastels. And the problem with that is it didn't do skin tones very well. It didn't do static colors very well. It doesn't really reflect what it is. And the fact is that it has not changed. Even today, they're still testing CRI based on those 8. So anytime you're dealing with somebody that says it's got to be this, remind them of that. Remind them that that's all they're getting is those 8 colors. LED chips, a lot of different chips that are being used on a lot of different fixtures nowadays. They range everything from static LEDs to chip on board, which is big round LEDs that's just a linear plane. Issues between them is how they use them and how we can control them. In this case, optics are put on them. Sometimes there are optics that are put on multiple LEDs. We use in area lighting sheets of LED optics that come on one big panel that cover 40 or 60 LEDs at one time. Get very close to the LED that allow you to control it very well. But you can't do that with a large LED plane because the LED has such a large surface area. The most you can hope for out of it is to just give you low glare and bend a little bit. Commercial LED lighting and low voltage, there's different styles of fixtures. They range everything from bullets to large floodlights that are lighting the facades of buildings. They're everything from a small 1-inch diameter, even smaller, to fixtures that are almost 2 feet by 2 feet in size. And again, depending on the wattage and the amount of heat sinking they need, that's the issue, is sometimes you need such a big platform to put out that much wattage. Commercial LED lighting, this is actually a product that I was involved in the development, those two, and they do a great job. They put out an enormous amount of light. So when you're talking about product, especially when they give you a competitor's product, you pick it apart. You find things about your product that are specifiable. In the spec business that I work in, we call it a spec lock. A spec lock is a thing about a product that makes it specifiable that nobody else can do. And if you have one of those, it's great. If you write a project specification that nobody that can beat it, and you have the support of an architect or an engineer that says we're going to hold it, you're guaranteed an order. And that's what I deal with reps all the time. How do I give you the highest probability of writing an order? I tracked quotes versus orders for a 3-year period with reps, and I found a relationship that when they were out there going and buying products to specify and to actually sell as a spec grade, they were successful 24% of the time, versus when they were going out there and just trying to meet somebody else's spec, they were only successful 10% of the time. Get in with the rep, who then gets in with the engineer or the architect and says, this is the better way to do this, and let you guys go in there and show them why your product has better value than what they were using. So when you work with a rep that does that, or has high quality people that do that, you're going to have more opportunities to sell more product. When you deal with lighting reps that are reputable, that you trust, you're going to want to go in and try to get specified with them, so you increase that amount of business that you get, not just from a residential standpoint, but from a commercial standpoint. If you become a member of the IES, you will be introduced to engineers. Engineers write the vast majority of specifications. In landscape lighting, you'll probably see landscape architects write more, but they will still go back to an engineer to put it on a drawing, because they cannot create engineered drawings and get them through code enforcement. Getting to know those people, getting in those meetings, sitting in on IES meetings, going to training with them, get you familiar with who they are and what they do. So those are things, when you start to learn who these guys are and who the specifiers are, whether they're landscape architects, engineers, architects, lighting designers, reps, ESCOs, everybody dealing in those markets has a need for somebody with the expertise and the knowledge to actually lead them down that path. LED changes everything. So final thought, LED lighting can deliver real energy, real maintenance, and real environmental benefits. Everybody knows that if they've been doing it for any period of time. And as an industry, we're working to spread knowledge and try to make people aware of what LEDs are doing and why it is such a great market and great product.